Hey guys, I'm back. I pulled up the MLSO run. We didn't get much. We got one image on this one. As you can see, this is for today, 10/29. And it was recent. I must have just downloaded this. Oh wow, look at all that stuff flying around. There's another one. This is the cropped image, same K coronagraph. Getting four images on there, three images. Four images, and you always get double on this that you do on the one that's not cropped. Got a few more on this bigger one, so you got I think 8 on the cropped side, and you get or 10 on the cropped side. We're getting 5 on this side. So you can see there's a lot of stuff flying around. There's the Ram B. So what I showed you this morning, same thing. 10/29. It's around 11 p.m. time in Melbourne, Australia. Like I showed you this morning, 1340, you can start seeing some light there. More light at 1350, 1400, which would be 11 p.m. Melbourne, Australia time. There it is. Whatever it is, I submit it's a planet and it's light beam here. Well, there's a couple of light beams, but notice how white it is. It's being reflected off the sun simulator. And if you look at the moon, how white and bright that is, it's also being lit up and reflected by the sun simulator. I would maintain okay, ISWA, that stands for Integrated Space Weather. I had to pull that up just to check. I think I said it was International Space Weather, which that wasn't correct. It's a NASA website, nasa.gov. Pulled up the Geospace latest run. Density's looking pretty crazy. Yeah, I know Halloween's coming up. No, that's not a ghost. That's the cut plane. It's the equatorial plane. It's the Y cut, looking at sideways view of the magnetosphere. It's like a cut plane, so they cut it, and that's like a slice, and then you're looking at the side view of it. That's the Z cut, the north-south, looking from the top of the planet down. So we're above the planet looking down, on the side of the planet looking sideways. It's showing you the density. The solar wind pressure, been looking at the last couple days, it's been pretty much the same. Almost at equilibrium from what's coming from behind the Nemesis side, or Herculobus, whatever you want to call it, and then the sun side coming from our sun. That's the velocity, same deal. The Y cut plane, looking from sideways view. And that's from looking over top. This is just all data they're taken from these GOES 13 and 14 spacecraft that go around in this geosynchronous orbit, 22,236 miles above the Earth, plus or minus 5 miles. So all this data is coming from these spacecraft. It's basically all the data inside the magnetopause. Maybe it goes out a little bit further. One thing I wanted to show you was this. Now these blue ones are supposed to be interplanetary magnetic field lines. And we've been having, well, there's only 9 planets and 1 sun normally, right? So we should have 9 of them. Now that Nemesis has been in the picture for the last several years, been getting a lot more of these blue interplanetary magnetic field lines showing up. So we got 2 suns, plus Nemesis is supposed to have about 7 planets in its system, the Nibiru system. So that would be 32 altogether, but I mean, they get scrambled up a lot. But just today on this run, look how really scrambled they're getting. And look at all the instability out in front of the planet where these field lines get broken. And well, as I conjectured in my hypothesis that that big planet passed ACE and it has a magnetic field, so some of its field lines are raking the Earth, and that's why you get these solar wind fluctuations. See all the different levels coming in of it's either velocity or density that's being measured there by that color coding. Well, it's not reflected on ACE. As you can see, the solar wind speed's pretty constant. It's low. It's below 350. Normal is 400 to 700 kilometers per second. Density, that's been a little more fluctuated. Well, this is all stuff being read in front of the L1 Lagrange point, which is 930,000 miles out here, and ACE and Discover are parked out here, reading all the solar wind data coming in. So there has been some fluctuations in solar wind density, but I still contend that with all this severe backside pressure showing up from Nemesis behind the Earth, of course it's going out beyond the Earth too, so that's affecting the solar wind density even out past the L1 Lagrange point. So some of this stuff is piling up, and of course it's got to be piling up in here too, in this dead zone where there's no satellites that are available for us to see that are measuring the space weather data. So all we have is the ones going around here for ISWA in the geosynchronous orbit. And then we have ACE. So there's got to be a bunch of solar wind density piling up in here, and I think that would be reflected by the bow shock. See how this bow shock gets compressed continually? It's going up and down. And the solar wind, you can see the color coding here too. So this is a Y cut. This is looking, if you're sideways to the planet, you're looking straight across the planet. And it's also a cut. So it's a cut plane of the magnetosphere, magnetopause, like that. And then you just looking at a sideways view of what it looks like from the east-west position. And this is the Z cut looking, say you're right above the Earth and the spacecraft looking down on the planet. This gives you the solar wind direction, these arrows, so you can see we got a whole bunch of solar wind coming from behind the planet. See how those arrows turn, face the Earth, and they're getting all screwed around, coming around this way and that way. So that's where you're getting all these solar wind speed numbers from Nemesis. It's not from these ISWA readings or Discover readings. See the solar wind speed. And there's the density. And this density on the ACE and Discover are sort of starting to match up a little bit more. And I'm seeing less of that splashing effect, although you can still see it here on the temperature and some back here, but it's not showing up out here as much anymore. So whatever that big planet that was affecting these readings on ACE, maybe it's getting far enough away. I mean, after all, it passed ACE around October 16th. That's when we quit seeing the big 8-minute gap, or nine-hour gap. Here's the latest 4-day plot. I showed you the two this morning. Those are the two gaps showing up at 1900 and 2200 hours on the 28th. Here's the last 6 hours. And at 1900 and 2200 well, there's another gap. So there's a gap to 2200, but not to 19. So there's still probably one of the moons of that big body planet that passed ACE on the 16th. Still blocking some of the data. As you can see on Discover, all the data is making it to the Earth. There's no data that's being blocked out, and then you could see on Discover there's no data gaps. So let's go back and look at this some more. I mean, so look at all these. Here's what I'm thinking. That big planet that passed ACE on the 16th and been headed toward the Earth. So that's been like 12, 13 days ago. Got to be getting pretty close. And I think some of these blue field lines that are showing up in front of the Earth, and also some of these blank spaces where the field lines get pushed aside. You see all the different velocities and solar wind densities coming in by the color coding. Look at all that. I would think that's probably, instead of interplanetary magnetic field lines between the sun and one of our planets or one of the Nemesis planets, I think some of them are actually field lines from that big planet piling up in front of the Earth that passed ACE on the 16th. See what I'm talking about? Look at all those field lines. And then look back here. Watch these black field lines. Normally they're about that color. Look how dark they get. Think that planet, look how dark. And look how it's all void here. So I think that planet's magnetic field is maybe connecting to the Earth, and it's strengthening, or it's reacting with the Earth. So these polar cap field lines are getting darker. So I would submit that that means they're getting stronger. I think it's due to that influence of that planet. And look at these crazy field lines. Look at that one. It's crazy stuff, guys. That's all I could say. Look how it went down there. I mean, big planet. I think it's getting pretty close, and its field lines are starting to interact with the Earth more and more, and its magnetic field's interacting with the Earth because it's blowing up all that space in front of the planet. We're getting a lot of voids there, and look at that. That's a big void. So I don't know. We'll see how it looks tomorrow. I'll try to put one up in the morning, and you see how the black field lines close, and look how scrambled they are. But when they close, these are the black field lines, the polar cap ones. And when they close, that's when they're trying to ward off all this backside pressure. So that happened right at the end of the run. See all the backside pressure building there? That's at 2049. So let's go back to 2049. So that's when they started closing. So all that backside pressure's coming in. And so they close up, pull as much power as they can from the Earth. Look how far out they're extending. These are Earth radii here. So every one of these is 4,000 miles roughly. So they're extending way past the 400,000 miles. Oh well, running out of time. God bless. Peace, and I'm out.